So if you're in the data world, you know just how powerful a well-structured database can be. But what happens when your data gets too big, too varied, or just too fast for those traditional systems? Well, today we're diving into the solution that has totally revolutionized cloud data storage, the data lake. Let's get into it. Here's what we're going to break down. First up, what's the real difference between a data mart and a data lake? Then, we'll get into the surprising power of keeping your data in its raw original state. After that, we'll see how a data lake can handle the incredible diversity of modern data. And of course, we have to talk about the dreaded data swamp and how you can steer clear of it. Finally, we'll look at why a purpose-built service, like Azure Data Lake, is such a game changer.
Okay, so most of us are really comfortable with the whole idea of a data mart, right? It's that highly structured, super refined source of truth we use for business analytics. And for that job, it works beautifully. But what do you do when you're hit with a flood of modern data that just refuses to fit into that neat and tidy box?
You know, this analogy is really what kicked the whole thing off. Just think about it. A data mart is like a store of perfectly bottled water. It's been cleansed, it's packaged, it's ready for one specific purpose: drinking. The data lake, on the other hand, is the massive, natural body of water it all came from. You can examine it, you can take samples, you can use it for anything you can possibly dream up. It's a completely different way of thinking about data.
And this comparison really gets to the heart of it. A data mart uses what we call a schema-on-write approach. That means you define the structure first, then you scrub and transform all your data to make it fit. Perfect for business analysts. But a data lake? That's schema-on-read. You load all the raw, messy, untranslated data first, and you only apply a structure when you're ready to analyze it. This makes it an absolute playground for data scientists and developers who need that kind of flexibility.
Now, this whole idea of storing raw data can feel, well, a little weird, especially if you come from a database background. Your gut instinct is to clean and structure everything right away. But holding back on that impulse, that is precisely where the data lake gets its power.
Which brings up the obvious question, right? Why not just transform everything immediately? I mean, why bother storing all this raw, messy data? What's the actual tangible benefit of doing that?
Okay, so there are 4 huge benefits here. First, it makes experimentation so much easier. Data scientists can just dive in and explore the original data without being boxed in by some predefined structure. Second, it future-proofs your analysis. You might need an insight tomorrow that you couldn't even imagine today. With the raw data on hand, you can always go back and find it. Third, it's the ultimate rollback plan. If something ever goes terribly wrong in your data warehouse, you can rebuild the whole thing from that perfect untouched raw data. And finally, with cloud storage being so cheap and basically limitless, you never have to throw data away. Every single byte is a potential future asset.
All right, let's talk about variety. Because the modern data landscape isn't just neat rows and columns anymore, is it? We're dealing with this huge, messy diversity of data formats. And honestly, traditional databases just weren't built for that world.
So the big question is, how does a data lake handle all this stuff? What are you supposed to do with, say, images from a factory's quality control line, or video feeds, or those semi-structured JSON logs that your app is spitting out? The answer is actually pretty beautiful in its simplicity. The data lake, it just doesn't care. It is designed from the ground up to be a universal storage place for any kind of file of any size. Period.
And what's so cool about this is that everything can live together in one spot. Your standard tabular data, like CSVs and Parquet files, can sit right next to your semi-structured JSON and XML, and all of that can sit next to completely unstructured stuff like images, videos, audio files, not to mention operational data like database backups and log files. Having all this data co-located, well, that just opens up some incredible possibilities for analysis.
But of course, all this freedom comes with a really big responsibility. The single biggest fear, and the most common reason data lake projects fail, is the risk of it turning into a data swamp.
Yeah, I hear this one all the time. That sounds great, but isn't it just going to become a giant, unusable mess? And you know what? That is a totally fair question. So what exactly is a data swamp? And more importantly, how do we stop it from happening?
A data swamp is pretty much what it sounds like. It's a data lake that's become so disorganized that you can't find anything, you can't trust the quality of what you do find, and getting any value out of it is a monumental task. It's basically where data goes to die, which is the exact opposite of what we're trying to do here.
The antidote, the solution, is structure. Not a rigid database-style schema, but a well-thought-out, logical folder structure that creates layers of curation.
A really common best practice is to have at least 3 main folders. First, a raw folder. This is where data lands, completely untouched, organized by where it came from. This data should never, ever be changed. Next, a clean folder, where you've taken that raw data and standardized it, validated it. Finally, you might have a warehouse or transformed folder, where data is aggregated and modeled, all ready to be used by your analytics tools. This layered approach is what brings order to the chaos.
Okay, so we get the concept. Now let's get practical and talk about the tech itself. Because while you could use a bunch of different storage systems, using a purpose-built enterprise-grade cloud service like Azure Data Lake gives you some absolutely massive advantages.
And that leads to another great question. Why bother with a specialized service? I mean, can't I just dump all my files into a standard object store like Azure Blob Storage and call it a day? The answer really comes down to one critical technical feature: the namespace. See, standard object storage has a flat namespace. It only pretends to have folders. So if you rename a folder that has 1 million files in it, what you're actually doing is 1 million separate, really slow copy and delete operations. But Azure Data Lake Gen 2? It has a true hierarchical namespace. Folders are real things. So renaming that same directory is a single, instantaneous metadata operation. For big data analytics, that difference in performance is absolutely monumental.
This table really sums it up. Blob storage is fantastic for general-purpose files, but Data Lake Gen 2 is built from the ground up specifically for big data analytics. It's got that hierarchical namespace, it's got an optimized driver for analytics, and its security controls are way more granular. It's the right tool for the job.
All right, let's pull this all together. What are the big takeaways? First, data lakes are the perfect complement to data marts designed to handle raw, diverse data at a massive scale. Second, by storing data in its original form, they unlock incredible new potential for data science and future-proof your analytics. Third, a smart folder structure is absolutely critical to avoid creating a data swamp. And finally, using a purpose-built service like Azure Data Lake Gen 2 gives you the performance and security you need for any serious analytics workload.
And that really brings us to the final thought here. The whole promise of a data lake is that you don't have to decide up front what data is valuable. You can just keep all of it. So the question I want to leave you with is this. Now that you can store everything, what amazing undiscovered insights are just sitting there waiting to be found in your data?
Hey, if you found this explainer useful, please do me a favor and share it with your colleagues. And of course, make sure to subscribe for more deep dives into the technologies that are shaping our world. Thanks for joining me.